My name is Rasika Devar, Division E, ITDS, and my topic for today is physical operation PN junction diode and characteristics of PN junction diode. What is PN junction diode? A PN junction diode is two-terminal or two-electrode semiconductor device which allows the electric current in only one side direction, which blocks the electric current in opposite or reverse direction. There are several types of PN junction diode. The first one is unbiased PN junction. The p-n junction in which non-external voltage is applied and charge is carried crossing the junction is called unbiased p-n junction or zero bias p-n junction. Due to doping, there is a large number of electrons in the n side but very few numbers of electrons on p side. Because on the p side the electrons from the electrons are minority carriers, and whenever the p-n regions are joined, then the electrons from the n side starts diffusing towards the p side. So whenever the electron enters the p-type region, then it becomes the minority carriers. Whenever the electrons leave this n-type region, it leaves behind a pentavalent atom. So due to that, it will become a positive ion, and whenever the electron enters the p-type region, it will get recommended with the whole of this trivalent atom. It forms a barrier potential. This action continues until the voltage of the barrier repels further diffusion. The next is forward bias p-n junction. Forward bias occurs when a voltage is applied across the solar cell such that the electric field formed by the p-n junction is decreased. The p side of the diode is attached to the positive terminal and n side is fixed to the negative terminal of the battery. The applied voltage is opposite to the junction barrier. Due to this effective potential barrier and junction width decreases with further results in more majority of carriers flowing across the junction. Moreover, the amount of voltage required is also less for the complete elimination of the barrier. Forward bias p-n junction forces the majority charge carriers to move across the junction. Due to this reason, there is a decrease in the width of the depletion layer. The number of holes and electrons are combined and each other once the junction is crossed. Each hole in p side combines with an electron that is from the n side. Due to this reason, a covalent bond will break and an electron generated from the covalent bond move towards the positive terminal. There is a formation of electron-hole pair. Holes carry current in the p region and electrons carry current in the n region. The next is reverse bias p-n junction. When the positive terminal of voltage source is connected to the n-type region and the negative terminal of the source is connected to the p-type region, the p-n junction is said to be in reverse bias condition. In this condition, the electrons, which are majority carrier in this n-type, will get attracted towards the positive terminal of the battery, and similarly holes on the p-side region will get attracted towards the negative terminal. And due to that, the more ions will get created near the junction. So we can say that the width of the depletion region will increase. So in the reverse bias condition, as we increase the reverse bias voltage, the width of the depletion region will further increase, and due to that the depletion region offers a more resistance of these majority carriers. We will get current due to the movement of these minority carriers. Next is characteristics of PN junction diode is a curve between the voltage and current through the circuit. Voltage is taken along the x-axis while the current is taken along the y-axis. With the help of the curve, we can understand that there are three regions in which the diode works, and they are zero bias, forward bias, and reverse bias. Zero bias. When the PN junction diode is under zero bias condition, there is no external voltage applied, and this means that the potential barrier at the junction does not allow the flow of current. When the PN junction diode is under forward bias condition, the P-type is connected to the positive terminal while N-type is connected to the negative terminal of the external voltage. When the diode is arranged in this manner, there is a reduction in the potential barrier. For silicon diode, when the voltage is 0.7 volts, and for germanium diode, when the voltage is 0.3 volts, the potential barrier decreases and there is a flow of current. When the diode is in forward bias, the current increases slowly and the curve obtained is non-linear, as the voltage applied to the diode is overcoming the potential barrier. Once the potential barrier is overcome by the diode behaves normally and the curve rises sharply as the external voltage increases and the curve obtained is linear. When the PN junction diode is under reverse bias condition, the P-type is connected to the negative terminal while the N-type is connected to the positive terminal of external voltage. This results in an increase in the potential barrier. Reverse saturation current flows in the beginning as minority carriers are present in the junction. When the applied voltage is increased, the minority charge will have increased kinetic energy, which affects the majority charges. This is the stage when the diode breaks down. This may also destroy the diode. Applications of PN junction. PN junction diode can be used as the photodiode as the diode is sensitive to light when the configuration diode is reversed bias. Second, it can be used as a solar cell. Third, when the diode is forward bias, it can be used in LED lighting applications. Fourth, it is used as a rectifier in many electric circuits.